lesson, which is interpreting geometric diagrams, which is basically what assumptions you can make from a geometric diagram. So certain things that you can make assumptions about and certain things you cannot make assumptions about. Then we're going to do a little activity, and then I'll give you guys your homework for Friday. Which, then you guys have a quiz on Friday. We probably will not have time to answer questions because Friday has a shortened periods with it being the PEP assembly, okay? So you're probably just going to have to turn stuff in. So you guys ask questions about proofs already, that's fine. There's nothing really that's directly related to this on the quiz, so it should be fine. This is more for when we get to proofs on Monday, like using it, okay? So don't really worry too much about that. The other stuff that you've learned all week, though, like counterexamples and conjectures, that will be on there. Conditional, converse, and biconditional. The law of syllogisms, and then algebraic proofs. Again, if you go onto my classroom, you will see a Google form that lets you take like a quiz. It's not going in the grade book, it's for you guys, okay? So what you cannot assume from a diagram. So you cannot assume these. So this is not assumed. So do not assume these things. First of all, you cannot assume that a diagram is drawn to scale. If there are no lengths specified, then any side could be the shortest or longest side. I don't know how many times I made up random examples and my angles are the wrong angles because it's just a random example, right? So I'll draw an angle that's, a linear pair, and I'll put some things inside of there, and the obtuse angle ends up being where the acute angle is, and the acute angle ends up being where the obtuse angle is. You cannot assume a diagram is drawn to scale, all right? So just because you think it looks like it's 50 degrees does not mean it's 50 degrees. An angle is a right angle unless it's specified. So the only way to know if an angle is a right angle is if it has a mark or it tells you that it's 90 degrees or that it's perpendicular. So if you do not see that mark in there, you cannot assume that it's a right angle. If it just looks like two lines intersecting at a right angle but doesn't have that square in there, you can't assume it's a 90-degree angle unless it has that marking. Lengths of line segments that appear equal are equal unless specified with lengths or congruent marks. So this is unless it looks like this. So if I gave you two segments, these two are congruent if I have the line markings in there. Do you guys see that? This single line marking means they're the same. But if I do not have those markings in there, I cannot assume they are the same. That goes with angles too. Just because two angles look the same does not mean they're the same unless they have the angle marking inside of them, meaning that they're the same. So the only way you can assume that two lengths are the same or two angles are the same is if they have those markings that mean they are congruent. So anyways, that goes with this one. Sorry, I went a little bit ahead of myself. And then lines that are parallel or perpendicular are specified. So perpendicular uses this symbol. Parallel uses this symbol, just so you guys are aware. Parallel lines will be marked with arrows. Those arrows mean that they are parallel to each other. If two lines are perpendicular, they typically have a 90-degree mark. Okay. So those are the things you cannot assume unless you have those markings in place. Do you guys have questions for me so far? All right, when you're ready, we're going to talk about things you can assume. Then we'll talk about do some examples, and I'm going to have you guys do a little activity. All right, what you can assume, not, this is things you can assume. You can assume any line or line segment that looks straight is straight, meaning that if it is straight, if it looks straight, then it is straight. So that means if it is straight, you can decide like collinear, if there's angles on it, you can decide to add to 180, that kind of stuff. So if it looks like a straight line, it's a straight line. A polygon is convex or concave. You can see that just by looking at it, right? A polygon being concave means there's a side that has like a that can go into it, like one of the sides cuts through the pieces, you can assume that. We've already done that. Something you know as a result of a definition, property, or theorem, not assuming but deducing it. So for example, rectangles have properties. So if it tells you that it's a rectangle, you know that opposite sides in a rectangle are congruent. You also know that all the angles in a rectangle are 90 degrees. You also know that opposite sides of a rectangle are parallel. That's not assuming. You're using the properties of a rectangle to decide that. That is okay. And then specific marks indicated in a diagram. So again, we're going to talk about lengths. So if two lengths are the same, they'll have the single dash mark. If angles are the same, then they'll have that. If two lines are parallel, they'll have arrows. Oh, that's not parallel lines. I just did that twice. Sorry, congruent lines. Segments. Sorry about that. All right, so those are things that you can assume if they are given to you. So we're going to just look at two diagrams, and we're going to do this activity for a little bit, and then before the bell rings, I will get you guys your homework for tonight. Hopefully most of you finish the proof on it. So what can we assume from this diagram? Tell me something that you can conclude from this diagram. Which one is a straight line? Well, we don't call lines by 3 letters. What is it? How do you call it, though? Line AB. No, you don't use 3 letters, guys. So it's line AB is straight. You can assume that.
Wait, if you said AC,
that's also correct. But if you use 3 letters, that is not correct. If you would have said BC, that's correct. What's something else you can assume from this diagram? Hannah? So angle ABD plus the measure of angle DBC. Oops, I forgot the angle symbol. Equals 180 degrees. They form that linear pair. What else can you assume? Brandon?
Measure angle DBE. Oh wait, never mind.
You could do something with DBE. You could say the measure of angle DBE plus the measure of angle EBC equals the measure of angle DBC. That's just the angle addition postulate that you guys learned. But it's not 90 degrees. Do not say that. You can't assume that. So I'm kind of glad you brought it up, though, because it does look 90 degrees, but it doesn't have the marking. So these are just some things that you can conclude on this one. So it's really good that you caught yourself on that, Brandon, because, yeah, it looks 90 degrees, but can you just assume that from a diagram? No, it needs that square in it for it to be 90 degrees. So go ahead and write some of those down, and then we're going to look at the next one. All right, what can you assume from this diagram? Yeah.
line AB.
AB is straight. What's something else you can assume, Bryce?
Angle ABD is 90 degrees.
Angle ABD is a 90-degree angle, right angle. What's something else you guys can assume? Madison.
AB is equal to BC.
Yep, those little line markings in there. I'm going to say segment AB is equal, I'm going to say it's congruent in this case. They're the same thing, equals BC. Because of these single dashings, they mean they're the same. What's something else you can assume? There's one more, there's more than one more thing, but there's one more big thing that you can assume. Mariah?
Angle DB
So angle DBE is congruent to angle EBC. So there's some other things that you could talk about. Because this is 90 degrees, do you know what do you know about this one? What is this one then? No, if it adds to 180, that has to be, that one has to be 90. So don't those two angles, aren't angle DBE and angle EBC complementary? Because they add to 90. Also, don't you know that they're both 45 for that to add to 180, right? Because they're the same. So there's so many things you can write there, all right? So that is the notes for this part.